Okay, now as we discussed, so we will be starting with data visualization module, and in this module we will be making sure that you will be at the end of this module in the position to conduct uh, uh, exploratory data analytics on any data set that you're getting, and also getting familiarities with any other optional softwares, which in this course we will be making sure that you will get familiarities with Tableau, which is one of the very famous within the industry software for data analytics and data visualization. I have an optional model for you as well on Power BI. If someone is interested, then they can join, and we will be seeing if how much interest is there. If the interest is huge in numbers, then we will be conducting a session on Power using Power BI as well. So they are both similar softwares actually, but the point is that it's like Google Sheet and Excel, yeah. So different companies, but they have both of them. They have their own pros and cons as well. And to go to the data visualization, it's very important. It's very important because you won't be a data analyst at the end if you don't know the data visualization and if you don't know how to conduct exploratory data analytics. And what is that? We will be coming to that, and I will start our presentation. So I think uh, um, you had our presentation at the beginning that we had conducted the presentation to you. In that presentation, we had a chapter there called data visualization. Under that chapter, we explained to you already in the foundation of data analytics course that why data visualization is that much important. Um, and these are the softwares that we said here: Python and Tableau, Microsoft Power BI, Google Data Studio, Excel, anything else. So um, data visualization actually it is the only part in data analytics that it attracts attention. Data visualization is a bridge between a technical guy and a non-technical guy. If you're going to be a data analyst at the end, no one will you don't you won't have any value as a data analyst at the end of if you're analyzing a data set and bringing numbers and calculations there. You know why? Because currently artificial intelligence is doing it better than you. If you upload something a data set, so that data set will be much more better than you analyzed by artificial intelligence by these chatbots and generative AI chatbots. So that is something that actually then what differentiates us from the AI from the Gen AI generative AI chatbots? The only thing which differentiates us is that how we are in the position to tell that story, to visualize those numbers and tell that story to our audience. Machines, they cannot do that, and machines they don't know how to do it actually. They can bring you visualizations, but they don't have that type of understanding of small nuances, how to tell a story actually, and while considering the audience as well. So this is how it differentiates you from a machine. If you're so this is one of the most important modules, and I hope you will excel these skills at the end in practice a lot, because currently right now with the speed of Gen AI development, everyone will be asking you that why, for example, this is not working, data analytics and all these things. But that's not the case. It works, and companies still they're hiring a huge number of data analysts all across the globe. And why that's and this is the only thing that you have to be in the position to tell a technical story to non-technical audience. Lot Data literacy is one of the critical things. Lots of people they don't have that they're not data literate. So for them, bring a story, visualize something, and tell them, okay, this is it. Instead of bringing all those numbers, sheets, in calculations. Yeah, so this is how it's very playing a key role and important. These were different type charts that we already studied in our previous lesson, and this was what is a good, what makes a good visualization. This was the McCandless technique, and how that there should be some narrations on the visual as well. So we played a game as well, if you remember that. So this was just a few things, and also deceiving visualizations, as I mentioned to you, that these are from technical points of view, statistical and numerical point of view. These are uh, the same specifics, parameters, while different visualizations. And the most important thing that became that data storytelling is very important. That you have to have a narrative, you have to have visuals, and you have to have data. And then put a story up on that. So this is how the narratives work, for example. You have to define a problem, then central insight of that, and then a solution recommendation. So this is how the narratives will work. Today we'll be starting with our new module. It's called Why We Need Data Visualization. Actually, the, uh, humans, they are actually visual creatures. They made for and made for patterns and trend spotting. So this is how the specific of human beings. Data visualization is actually enhancing the understanding and retention of information, essentially in exploratory data analysis. And data visualization is a critical part of the decision-making process of data-driven organizations. So if you're working in an organization as a data analyst, and then you're bringing some charts to your CEO that, okay, now I have to have that you will decide upon the profit and loss within the company from finance point of view. So then no one will be in the position to take that decision. Currently, why data analysts are required? Data analysts are required that they have to extract very rapid, small, visible insights, outputs from the large data sets, because timing is very important. Managers, CEOs, and all people who are making decisions, for them it would be very difficult to proceed and go all those numbers in those sheets. This is why data analysts are required, that they have to generate insights and visuals for decision to ease the decision making. And this is the critical role. So as you know, the decision making within data-driven decision making is one of the key aspects of a success within an organization. And who can bridge that gap? That's the data analyst who can bridge that gap. One more thing from um, a technical point of view, 90% of the information absorbed by the brain is visual. Only 10% remaining is other type of information which human brain can absorb. So this is how you have to excel mm, this course. There are some pitfalls of data visualization as well. I just list some of them, but um, that we have to be cautious about that. So data is for everyone, so we have to proceed with caution. And why that's with caution, then I will tell you at the end that uh, we should exclude biases in our decision makings and in our data-driven decision making in our analytics. If that bias is still there, so then uh, data will not be for everyone actually. Yeah, so for a specific audience or for a specific category. So then uh, generating a specific decision, unbiased decision from that data will be impossible. This is why whenever you're analyzing something, you have to come out of all your biases, all whatever you have in your mind. Just focus on data from technical point of view. Sometimes whenever you're starting analyzing something, you have some biases already, some assumptions in your mind. Huh? Okay, I'm analyzing this data set. Yeah, just assuming, for example, if you're analyzing a data set, profit loss from a company, yeah, and recently you saw that the stock of that company has lost something, yeah, and in the stock market, then automatically you have a bias in your mind. You have an assumption. Okay, stock has been decreased, and maybe that there is a loss in the company. Yeah. So this is a bias. Yeah. So and whatever analytics you're doing, if you're not coming out from this bias in your mind, that just put aside how the company is performing, just focus on data and see what the data says, then then I think that would be a data-driven decision. So this is how it's very important to all the time consider. Poor numerical literacies, non-data professionals, it's one of the things which all the time you have to be very good with your storytelling. For example, if you're presenting a bar chart to someone, and then you're assuming that that guy will understand what's the bar chart and how it looks like, um, and you know that there is a low data literacy level, this is sometimes you're facing the problems. So make sure that you explain everything properly to your audience, non-technical audience. And if it's not possible only with visualization, put narratives there. So this is the example of narratives, for example. See uh, what happened. This is the example of narratives. See this visual, just in order to make it much more um, accessible to all people. So they put narratives here. See some text here, some text there. So in order to give them a proper understanding of how it looks like. Detachment between data and the context. So that's one of the things that sometimes whenever you're proceeding with the data visualization, you're diving deep into the data in a way that you're just forgetting your context, why you're doing actually at the end, why you're doing this data visualization. So all the time, keeping into consideration the problem for which you want to find a solution. Lack of experience of data analysts. This is one of the pitfalls of data visualization. You have to do it several times in order to understand it, to excel this skill and be at the top of it. And misleading visualization, as I mentioned. So sometimes you would be having deceiving and misleading visualizations, like this, for example. But be aware of that. So this is how it will you have to work. You will be starting with some techniques. I will show you some techniques of data visualization. In data visualization, for example, look at this. If this the first of all, you have to highlight the data. So what does it mean highlighting the data? A specific data point that you want to be presented and to be attracted attention, you should highlight that specific point. Otherwise, if you're just presenting um, a scatter plot or some line charts, yeah, these are line charts, yeah, and all of them, for example, gray, for example, all of them are gray color, yeah. So where you want to keep the attention of the audience. So this is why highlighting the data is very playing a key role. For example, in this example, I just loaded a data set. It's called pollution data set. This is the pollution data set. These are the cities, the air, the month, the day, and the amount of carbon dioxide and oxygen, ozone, and nitrogen and sulfur in the air. So this is how um, a small data set is here. If you just put a scatter plot of, for example, um, nitrogen, sulfur oxide, and you see this is these are the scatter plot. Okay, so you did a visualization actually. Yeah, you can put a um, proper title there. You can put grid lines, everything perfect. Yeah, but actually, what does it say? This visual. What you wanted to convey from this visualization? I wanted to convey, for example, if you wanted to convey in work specific with a specific city, then you have to highlight that specific city. For example, I want to uh, highlight a specific city. If I want to highlight a specific city, then that highlight that should be appeared on the scatter plot. That I should see that among all those other data points, where this specific data set, this specific city is locating. This is how, for example, you can do that. Another thing, this is how highlighting the data is working. Another thing which is very much important in playing a key role, that's called annotations. Annotations are playing a key role. You see this is type of annotation. Uh, this is type of annotation. Annotation means providing text into a specific point on a chart in order to draw the attention there. For example, trying to convey a set message. If yes, then use annotations. If no, needs to stand on its own. So there is no need to do that. Yeah. So this is how you have to decide. If you want to convey a set message specific to the data point, then you have to use the annotations there. Just look at this. This was the same chart. See, this is the same chart. Within the same chart, scatter plot. What I want to highlight actually, I highlighted the city. That's good. I highlight the data point. That's good. This is my data point of a specific city. But also, instead of that, I want to not highlight, but I want to just put an annotation, a text on a specific data point. See, in this scatter plot, there are several outliers, but very obvious outliers are, for example, this one, yeah. So these are the outliers. Let's point out the outliers. What we have done, we just put an annotation on these data points as an outlier to highlight that these points are outliers. So I hope you got how you have to highlight the data set and how you have to put annotations on a specific data points. This is playing a key role in data visualization. Now coming to the color in data visualization. Colors are playing a key role, very important and very obvious that you have to have to properly understand the color. Sometimes everyone thinks that this is just a simple thing, but the whole visualization is based on the color theory. It is not properly used, then your visualization is actually useless. And if it's that is useless, then you didn't convey your message to the audience. You didn't convey the story. If you didn't convey that, then whatever technical things and efforts you have done for weeks and analytics of the data, it's just waste of time. And so please pay attention to all those specific elements. The colors actually differentiate classes of data. It encodes continuous values, should be used very carefully. Look at this. Whenever you're looking at this picture, instead of just looking all at the yellow first, you automatically, your attention, the red is automatically grabs your attention. Because this red color is one of the colors which attracts the attention. So this is how actually they are the same shape, same data points, or everything is the same, yeah? But you automatically focus on red color whenever you're looking at this picture. So colors and using colors properly is playing a key role in order to attract the attention of the users into your visuals. It has also the misleading power of color. So this is the picture that it shows the misleading power of the colors. It shows the cubes of different sizes and colors. Yeah, with some cubes appearing larger, some cubes appearing smaller. So this is how colors can create visual illusions that distort perception. Bright bold colors like red tend to stand out more and can make objects appear larger than muted colors. This illusion can affect how viewers interpret data, leading to potential misinterpretations. So color is a key point. And how to all the time understand the color. And one of the things, for example, I used previously as well, but I just wanted to show to you this as well. We had a bar plot, if you remember, in one of our presentations. Where we have bar plots? In one of, hey, see this bar plot. If you just remove the age color, so see, if you just remove this one, this age color is playing a key role here, for example, putting a boundary on a specific value. So that's one of the things that you have to pay all the time, keep attention to. Here, the same thing happens. For example, if you have just these bars, these are just bars, yeah? But if you have a specific boundary around the bars, it differentiates bars from each other. You see, this is one of the good things about using each color whenever you're using a specific, for example, bar charts. If especially when they are very close to each other and there are lots of bar charts. So all the time, in order to not mix the bar charts with each other, you have to put a each color. I just put red here, but the red is not recommended, so you can put anything else in this color. Now coming to the type of color palettes, you have to understand use of color palettes. What is color palettes? We have continuous color palettes. We have categorical color palettes. For different data types, we have to use different color palettes as well. For example, what is continuous? So you know right now what is continuous. So ordered and lots of possible values, distances, sensor readings, volumes. These are all continuous numerical numbers. And not continuous, for example, there is no order or few possible values. For example, categories. Yeah, so these are not continuous. These are categorical values. Relatives scales. Yeah, scales, it means so very bad to very good. Yeah, look at this. So they just show it based on emojis here. Binary values, good, bad. For example, yes, no. So these are categories, different countries, different types of data types should use different types of color palettes, and they are very important. For example, if you use um, um, relative skills, for example, coming from bad to good, for example, yeah. So you have to use a type of skill that it should be starting for the it should be specific for the continuous color palettes. So it starts from the least light number to very light to very dark number. So this is the light color of that blue, and it's go to the darkest shade of that blue color. So these are the types of categories. You can assign this, for example, for the lowest score of your categories, and this to the highest score of your categories, for example. This is one of the things that you can work, for example. Or maybe for the categories, it is not having that much direct use. For the continuous numbers, for example, starting from the temperature, low temperatures, yeah, to the highest temperatures. Look at this plot, for example, ozone. Yeah, it shows different levels of ozone, different times of periods of air. For example, air 2015. Yeah, so within that year, it shows different levels of ozone. This type of visualization is also understanding. Okay, this very light is it means it's very low level of ozone, and very high is the highest level of that. But with that color palette, it's very difficult to differentiate. So you have to understand proper use of color palettes. A color palette that should be very easily distinguishable. Instead of using one type of color palette like this, you should use, for example, 2, 3 type of color palettes in order to distinguish between those. Look, like for example, here I can see it has the highest number of that uh, thing in that specific time of year. So see, automatically. But here, it's very difficult for you to distinguish. So you have to go line by line. The same, um, the same visual with different color palettes. See, in here, it's much more attractive, much more understandable. And you see this is the lightest line here, yeah? While here, if you just have a look, you think this is the lightest line, yeah? In this color palette, you think, oh, maybe somewhere here, yeah? These are, because there are lots of similarities. In this color palette, automatically it goes to this line, see? You find that this is the lightest one, for example. This is how color palettes, continuous color palettes are playing key role. One more thing in selection of colors, it's the color blindness. They're calling it color vision deficiency. Color vision deficiency is actually people, lots of people in our countries, maybe people, they have this disease, but no one is actually paying attention to that, and no one is actually predicting, diagnosing it actually. Maybe lots of people, they have this color blindness. But in Western world, they have these diagnostics, proper diagnostics, and everyone understands who has color blindness. Color blindness is in a way that people, it's for them very difficult to differentiate between specific tones and shades of a color. And they are thinking the same thing about several colors. You'll be coming to that. So, for example, in order from green and red, so all the time it's not recommended for a colorblind person to use for them. If they are in your audience and you're presenting something to them, you should not put these two colors, green and red, together. Because if you put green and red together, this is not a colorblind friendly visualization. And for them, it will be very much difficult to differentiate, and not even differentiate, but actually they will be just having a wrong perception of what you're presenting. In such things, in order, instead of using green and red, like very strong shades, you can use other types of colors, like this, for example. We also have neutral, encoding neutral values. For example, from the lowest value, from the -10 to +10, yeah? So in order to having a neutral value, so you're coming from a minus degree to this 0 type, and from 10 then going back to the plus. So you can have encoding of neutral values. For example, coming from strong of use two colors, this color and this color. Then use the shades of that color. Lower shades coming toward the neutral value, also lower shades coming toward the neutral value. So this is how you can use two colors and encoding a specific neutral value here. So this is the strongest, and this is the lowest. But whatever is in the center, which is, for example, just mention about the zero neutrality, for example, here. Then you can have lighter shades here. And go to the background. If you have a chart and look at this chart, and this chart shows this is a scatter plot. Again, it shows the carbon dioxide and also the nitrogen correlation. And look at this. This is a type of other third category that they have used for the coloring of these charts. Yeah, I'm using those on. Now look at these. These are very light shades. Yeah. In a white background, it's very difficult to differentiate. You can use other types of colors as well here, but one of the good things that if you don't want to use other type of colors, why? Because for example, you're working in an organization where this is their brand color, yeah? Lots of organizations, they prefer that you create charts in their brand colors. So this is one of their brand colors, and they want you to have such a chart. But instead, see, this is not visible. Look at this dot, for example. These dots are not visible. Instead of that, changing the brand color, you can just change the background, for example. If you just change the background, and background now input for example, a border. It has already border here, but it's white border. But if you just put the background, darker background, so the white border in the color gets differentiated. So this is how you can use different type of colors for the continuous color palettes. We have to understand also the categorical color palettes. We have categories, different types of categories. For example, cities, bird species, for example, countries, different things. For those categorical color palettes, you have to understand that just don't be very much surprised with all these codes. These are standard codes coming from the 𝗔𝗱𝘃𝗃 and coming from the matplotlib. These are all the qualitative color categories of, for example, of matplotlib. Each category has a name. Whenever you are using, so you can just put it. I remember one of your colleagues asked me at the beginning that how I should understand to use which type of colors and all those things. Yeah, that was a very premature question at that time that we were studying that. But now this is the place that we have to reply to that question, because when we are learning data visualization. These are all the sets of colors coming from matplotlib. For example, if you just put tab 20 color palette equal to tab 20, so all these colors will be referenced in your visualization. See, these are pairs of dark light of that color, dark light of that color, dark light of that, several colors with dark and light shades. These are all qualitative or categorical color maps. Coming to the 𝗔𝗱𝘃𝗃, from 𝗔𝗱𝘃 you can also just bring the color palettes. Quartiles, for example, data range, they are very important things, for example, as I mentioned to you. Coming from the first to fourth, yeah, you can just use one color but different shades, lighter shade, darker shade. For example, days of the week, coming from the Sunday, lighter shades to the Saturday end of the week with the darker shades. Relative scales, for example, happy this side, for example, sad this side. So it's coming from the neutral point, yeah. So starting from the neutral point, but it's still, as do you remember that we give a presentation of neutrality right now? This is the color, yeah. So this is how they use these two colors, yeah. So this side is, and this is the neutral. This is how you can use this, for example, this side and this side. The similar things you can use. Now coming to the matplotlib.org. If you just click matplotlib.org, this is the proper and put the color maps in matplotlib, for example. Yeah. So then in this file, you will have all the name of the colors in matplotlib library of Python, all the color palettes, different types of color. See, this is where this, for example, if you type Viridis, for example, this type of colors, the matplotlib will be using this type of color palettes, starting from this color, ending to this color. So this is the lowest and this is the highest. Look at this, what we have done here, for example. And this we used plasma, yeah. So this is from SNS color palette. So we will be coming to the SNS color palette. Viridis, look at this Viridis, yeah. So this is the Viridis color palette. I think this is the same Viridis color palette here. See, from this side to this side, this side to this side. This is how you can choose a specific color palette. This is the plasma in matplotlib, but we used it in 𝗔𝗱𝘃𝗃. So in 𝗔𝗱𝘃, I can show you. This is the 𝗔𝗱𝘃 color palettes. The same thing, 𝗔𝗱𝘃pydata.org. So if you're going to this website, so it gives you the whole list of colors, component of colors, number of color palettes, see different types of color palettes you can use. So there is no need to memorize all these things. Whenever you're using charts and you want to just do it a proper coloring, you can just visit the specific documentation of that specific platform. See, you can use different types of look, this is a colorblind palette from 𝗔𝗱𝘃𝗃. You can use that. Different types. See, magma, Viridis. This is color palette Viridis, for example. We use this one in here. See, we use this one here. This is plasma. We use this plasma here. These are the continuous color palettes. These are the discrete or continuous mapping. Yeah, so this is discrete and continuous mapping. This is how. Then you have to have the neutral value as well. So neutral value, if neutral is within the center. See, this is the neutral value within the center. So if you use this color palette, the lowest will be green, the blue, the highest will be around red, then the neutral point will be like this. Similarly, neutral point, you want to make it very much visible to the audience. You can use this. Diverging palettes. Diverging palettes coming from, this is called custom diverging palettes. Diverging palettes means that it's coming from minus to the plus side, yeah, from bad to the good side. So it's diverging. All diverging color palettes, they have a neutral point within them. So these are all the sequential palettes, color maps, for example. If you're just sequencing, yeah, from 1 to 10, for example. 1 is the lowest, 10 is the highest. So this is how you can use that. These are other sequential color palettes within the matplotlib. These are divergent color palettes. Those were from Seaborn. This is from matplotlib. See, these are all divergent, coming from the, for example, from the minus side to the plus side. This is the neutral type, or from ranking something, yeah, from bad ranking to the good ranking. This is the middle color. These are the qualitative, so we have different categories and miscellaneous color palettes. You can use that, but all the time, please pay attention that you should not use too much red and too much green within the same color palette. These are different types and numbers of all those color palettes that we have used previously. This is in regard to the color that you have to understand in all the range and things of color. Color theory within the data visualization. This is very important. Now let's understand. Okay, now you have to understand. You have the understanding of data visualization best practices, color theory within the data visualization, and also highlighting the data, annotations. All these are best practices within data visualization. Now, starting from that you are going to be a data analyst, and data analyst will be starting from what? From exploratory data analytics. If you remember, we presented something at the beginning. We mentioned that a data analyst starts with descriptive analytics. So it's describing the data set. Yeah. So descriptive analytics is a type of analytics that you are just looking around with the data, understanding the nature of data, how the data is there, what is there. It's all in examining the different relationships within the data structure, which is there. But now the good thing is, if you want to give this presentation of descriptive data analytics, or for example, diagnostic data analytics, for example, you have done a bit more diagnosis, yeah? So you want to present that, how you will use that presentation, how you will present that. You will be using data visualization techniques to present that. Now, okay, you have concluded, you have conducted a descriptive data analytics, but now you found some of the relationships are not working within the data set. Now you want to have to provide a understanding why it's happening. So you will be proceeding to the diagnostic data analytics. So how it's there, yeah, why it's there. And you want to understand it. Now, combining these both two, descriptive and diagnostic data analytics, and making any outcomes from the data, you can use it with a very simple technique. It's called EDA, exploratory data analytics. Exploratory, it means that you're exploring a data set with visualizations and then getting any insights from the data set. This is one of the important techniques of data analysts. And whenever you are starting with a data set, you have to start with these type of analytics. So I will share with you a small data set. So please download it. I'll share it in the chat. And let's start with that data set. Just assume that you will be starting your first data analytics project. Okay, I will just find where is my file. I think this is the file. Okay, now you have to have access to the data set. So from Google Classroom, I have shared the data set with you. And you will be having access to the data set. Yeah, you said that can be work on real-time example for it more clarity. So yeah, when you said this, I'm doing it actually. Do you have anything else? So I just shared that with you. Please, bit patience, okay? And again, good. Now you have to have a data set, I think, shared with everyone. Now let's start with this data set. Well, what we will do with this data set and how you can manipulate this data set, how you will work with this and conduct a ED with that. So let's start with saying that this is the okay. First of all, before going to all those things, you have to import the step one is step one. Whenever you are working with any data set, uh, you have to import the necessary libraries. Okay, so let's import pandas as PD, import numpy as np, import, for example, matplotlib 𝗵𝗿 PLT, and import 𝗔𝗵𝘃 SNS. These are all the required things that you have to do. And second thing, let's write it. Step 1, imports the packages in the dataset. Both of them, you have to import both of them. Let's gives this dataset a bit. Okay, good. Now I will upload this dataset. Okay, I uploaded the dataset. Now I have to copy the path of this dataset. Yeah, so I copy the path. Okay. Now I have to import the dataset here. This is the dataset of companies. Okay, so companies dataset is pd.read.csv of what? The dataset that I have. This specific location which I copied. Yeah. Now you have to run this one. And now you have to run this one. Good. And let's check if it is important or not. It is important. So this is the name of company. This is the valuation of company. Date joined. Industry of the company. Cities. Country, region. Continent. Year founded. Funding. For example, how much funding it has. And investors. Who are the investors there? So this is how the data set look like. Okay, now step 2 is the data exploration. Step 3 is the data exploration. You have to explore the data. For that, we have to do, first of all, I want to explore the only, for example, 10 rows of this data set, 10 first rows. How to do that? Anyone?
We will use the head function, sir.
Companies dot head, just put 10 rows. It will give me 10 rows of this data set. See, this is the 10 rows of this data set. Good. Now I want to understand overall. I want to understand how many rows and columns this data set has. In order to find how many rows and columns this data set have, what should I do? What should I use? Which
shape?
Company.info.
Yes, info is also going, but very short shape. Shape just gives you, this data set has 1074 entries, rows, and 10 columns. Now, in order to understand it, yeah, so properly, you know that this is 1074, yeah. But do you think that all these are unique numbers, or maybe they are duplicated as well? How to find the duplicates and remove it? For example, if you have duplicated numbers. Now, do you have the shape of that?
Yeah, we can use is duplicated function to see if there is any duplication of any rows. And if there is any duplication, we can then drop it with drop no function.
With drop duplicate function. With drop duplicate functions, if you just put drop duplicates, companies.drop duplicates. So it will just remove the duplicate, all the whatever is duplicated. So from that company file, it will be just dropping that. But in order to understand that after the drop, what happened to the file? So after the dropping the duplicates, still it has 1074 rows and 10 columns. Drop duplicates will not drop the columns, it will drop just the rows. But now see, it means that after dropping duplicates, what is our understanding? Our understanding is what? That we have
That there are no duplicates in the entries.
that there are 1048 companies. Yes? Within this data set. If there were any duplicated things, it would be dropped from here. But these are all the names of companies, so these are company names. Okay. So it means our data set has 1074 unique name of companies within this data set. Now, one more thing, that since we understand that the shape that is returned after dropping the duplicates is the same as the shape of the origin data, then we can say that duplicate was not found. So this is one of the things that we can do that. Another thing which is very important for us after this dropping the duplication is that we have to understand the data types. Now, how to find the data types? How to do that?
That would be companies.info.
Exactly, info is one of the things that it shows us. Select investor. See, there is one missing value here. Null and investor status. These are all the data types. So this is also one of the things that you can use for the info. This gives you a proper understanding of all those shapes and data type of the data set. One more thing which you can use, that is the
D-type.
D-type is one of another things. Yeah, we can use that as well. D-types. It gives you a simple column like this. This is the all things. So it means the company here, for example, the company column, it is object, it's a string, text. Valuation is text. Data joint is text. Industry text. City text. Only thing which is not text, it's interior, it's year founded. These are the things within this data. So question is, for example, here, how would we, for example, sort the data set? So sort the data is also very, very important for us. For example, after understanding the data types, and just go and understand that sorting of data set. So how we will sort the data set, the data set.
We can use the sort function and maybe data frame as well.
We can use the sort values, then using by what? Let's use by year founded. And let's make ascending to false, and then just 10 rows. You will see 10 first rows of the companies. Now this is year founded, 2021. So if ascending false, it means it will start from the latest year at the top. If ascending true, it will be, look, if it's ascending true, then it will be starting from the law in 1919. So there's a company called 𝗗𝗲𝘃𝗃𝗃. It has been founded in 1919. So it started from the very old one. But if you want to have a look at the recent ones, the recent company which was founded is called Phantom. It's founded in 2021. So this is how the sorting values are working. And look at this, for example, from these sorting, these 10 sorting, for example, 10 rows or for example, 20 rows. From this sorting, you can also understand different things. If you just have a look at the industry, for example, all these companies which have been founded in 2021, look at them: e-commerce, fintech, internet software and services, data management, e-commerce, mobile telecommunication. See, everything is relevant to technology. And this is the future, actually. So all data management, e-commerce, internet softwares, all these things have been established in recent years. So this is one of the very, very simple information that even with sorting you can get from the data set. Now, let's find, for example, how much companies have been sorted per year. Yeah. How to do that?
We can use group by
By
year founded.
Yeah, that's one of the things by year founded, that group by. But then after the group by, what you have to do, all the time.
The count.
Now, after the group by, you have to use a function. You have to use another column. And for that column, you have to use an aggregate function.
Yeah, for
Of
counting.
sum of something, or for example, or something else. And in order to avoid all those complexities, we can use, for example, as you said, count of something, yeah? Count of, for example, count of companies, yeah? Count of company, this, we can use that. But very simple thing is, a very simple thing, for example, if you have company and you have this year founded, yeah? Then just say value counts. These are all the years, and these are all the values counted. For example, number of companies, year founded. So for that, so it just gives you its type of that. But now we have to also sort it. Sort values, and let's make ascending to true or false. Let's make it false. Look at this. 2015 is the year where the highest number of companies have been founded. 155 companies have been founded. 1997, 1919, 1991, 79, all these other years, or the lowest number of companies have been founded per year. 95, only two companies founded. And then see after, this is how different years, different companies have been founded.
Can you sort it by the year founded?
Yeah, we can do that. We can already mention this at the previous time, that we can do the year founded as well with the in the value counts here. For example, within the value counts here, we can use the sort values as well. But right now we want the number of companies, which is how much highest number of companies founded per year. So this is now the thing that we are proceeding with.
Okay.
For example, 2015 is the year which highest number of companies have been founded. This is the largest number of companies in this data set, 1 per year. Now, question is, for example, this is now, as a data analyst, you understand this, yeah? But how to visualize it? How to make this, how to give this information to in a way that it will show in a very simple image that, okay, oh, how many companies, how has been, so in order to proceed with all these values, 1 yeah, how you will do that, how you will visualize this and prepare a visualization to us, to non-technical guy, that if he looks at the data set, then tell you, okay, good, now that's it. What do you think? What should be used here?
I think pie chart.
No.
I would say it should be a line chart to show the trend of the number of companies that was founded from 1997 to 2015, sir.
Somehow, one more options. Trend line chart is using for trend, yeah, trend of time and number of companies, yeah. This is one of the things that we can use that. But right now, that's one of the things. But right now, we want to understand the distribution, for example, of this number of companies founded. In order to visualize the distribution, what we are using?
Histogram.
Good. So we will be using a histogram. This is a simple function of SNS, Seaborn of histogram. Data, you have to say which data. That's the data set companies. What is the X? X will be the year founded. The title of this will be year founded histogram. Yeah? Let's use plt.show. So see all these decades, for example, 1920 to 40 to 60 to 80 to 2000, very few number of companies have been established. But the whole distribution and the whole density of establishing companies happened when? Between 2000 and 2020. So this latest 20 years. Line plot will not display this for you. Line plot will show you those numbers, yeah? So a line and a number there. But histogram also will give you the understanding of what? Of the density, for example. That how dense this latest 2 decades are there. So this is how we understand that the company is established within this is to decades. Now we have to understand one more thing about date joint. Yeah? There was a thing here. If you just this is date joint, yeah. So year founded and date. When the company unicorn status to when another company joined. For example, how would you transform the date joint? For example, we want to compare, for example, how a company was founded, unicorn company was founded, and how another company has joined it. For example, when one company joined unicorn status, yeah. So you know what is the unicorn status? Who can say what is unicorn means?
Basically, in the business world, unicorn status refer to those startups who have reached or exceeded 1 billion US dollars in terms of financing. So some of the ventures go through public, to what we call the initial public offering, where they offer the stocks to the public, and the companies reach their unicorn status because they are usually financed by capitalists or major innovators, major investors, the public, so those kind of stuff.
This date joined means that this company, which was established in 2012, had become a unicorn on this date. And it's exactly what Ashley said, that this is the understanding of unicorn. So when the company was started and when the company had become a unicorn and joined the unicorn. Now, in order to understand this, so we understand from the data types side, yeah, from the data types, that date joined is just an object. And this object working, it's not giving us a date, yeah? It's giving us a text. Now, in order to change the join date joined to a date and time format, what to do? Companies,
Yeah, we could use the assign type function, sir.
exactly, date joined will be assign type of that, or maybe there is for the date and time thing, there is another specific function from the Python, from the pandas. And that's very important, playing a key role. Because putting a date, it will just give you a date, yeah? But if you use this type of, for example, pandas2 date time, this will give you also understanding of date. Then you can then have a proper sorting and grouping by months, by dates, and also by years as well. So it gives you a very standard diving deep understanding of iteration within the date. You can do that. You will not understand it right now, but when we are going to next time using the other softwares like Tableau, like Python, like Power BI, then you will understand why this is very important instead of using just assigning simple date and just converting the whole column into data type column. Because then whenever you have a full column of date time type, it gives you lower iterations into months, into days as well. So that's also playing a key role. Now let's run this one. And see companies. Companies dot just simple info. Date joins become to date time 64. See it. Now that the date join column is in date time format, we should extract the month name from each value in date joined. This helps us obtain the names of the months when companies obtained unicorn status. Yeah. So let's create a month join column. So now we have a date join column. Yeah. Let's see which month, for example, these companies joined. How to extract month joined. So we can create a new column, companies, for example, month joined, it will be companies. Oh, sorry. It will be companies dot, not dot, but date joined to dt dot month name. You know why I was telling you that this is important to this date time? Because if you have a date time data type, then you can just extract the name of that month from that date type. So it automatically, then Python will understand that this is a year, this is month, and this is the day. So it calculates automatically. Now let's see, did this happen properly or not? If companies, head office. We have now new column, month joined. First of all, this changed, date joined changed from 7 April 2017. Look at this. This was the initial one, see? Oh, this was the year, oh, this was the ascending one. This was the initial one, see? Month 4, date 7th of April 2017. That was the initial one with the type of what? With the text type. When we changed it to date to time type, this type, it became 7th April 2017, 1st December 2012. Now, from this, we created a new column. We said month joined, and it just understands Python automatically that this is the month 4. Month 4 means April. It gives you the month name. See, month name here.
Sir, I have a question regarding this this additional column. Is it possible to move the month join column like next to the date join column?
Yeah, we will do that. Yeah, we will be coming.
Okay.
It's possible.
Thank you. Thank you, sir.
It's very possible. Now coming to the, now we have the months column. We extracted the month of each from the state. Similarly, you can use, for example, the companies. For example, years joined. Yeah. Years to join, and it will be the companies date join column, similar thing. Using another function instead of date dt.month.name function, we used dt.year function here. And then what to do? Make it minus from the company's year founded. What does it mean? It means years to join. It means how many years? Look at this. It means we have new column, years to join, 5 years. What does it mean? It means it is now 5 years after the founding, it joined the unicorn status. So it was founded in 2012. It has become unicorn in 2017 and 7th of April. And it has now 5 years that the company has joined the unicorn status in month of, for example, April. This is now the company is in unicorn status after 10 years of its funding. So it means different types of companies, how much time it took to a company from its founding year to become a unicorn. So you see, this is a very simple mathematical calculations. This years to join that, how much years it took them to join the unicorn. It is simple. From this date joined, we have to extract the year, for example. This 2017, yeah? We extracted the year 2017. And then we got only the year from this column. Then from this year founded, so this was 2012, the year it was founded. We just minus that, made a minus of that. This is how the company, the companies have been there. After the foundation of the companies, they joined the unicorn status. Now, the question is, for example, would you like to gain more insight on with respect when companies attended unicorn status in Y, for example? Yeah. So let's, for example, get some more insights on some specific years, for example. Yeah, understand how when we want to understand the data set and how specific years, insight on specific years. For example, we have an assignment from this. For example, we can also see this 2015 was the highest number, yeah? So why happened all in 2015, for example, yeah? So we can just target a specific year, then gain more insight on a specific year. That's one of the things. But also, for example, we can just target a specific another year, for example, then we see what happens in that specific year. Right now, for example, we saw that in 2015 there were lots of companies who founded here. See, 100. Let's see what happened in 2015. So get a specific insight from 2015 year. So it means filtering the data set on a specific year. So how to do that, for example, yeah? So just say companies 2015, yeah? Make it a subset of data set, yeah? So just put it in a way that it will be companies where companies year founded dot dt dot year. So this you have to take from this year founded only the year, yeah. So but still we can use dt dot year is equal to 2015, for example. It didn't work for dt year because this founded year is already in year, so it is not in a date joint format. So if you're analyzing the year joint, date joint here, so then we have to put the dt.year function here in order to get only the date joint from there. So this is how in 2015 it filters the data on 2015, and it gives you only those number of companies which have been established in 2015. So we can use a time interval, how we could observe trends in the companies that became unicorns in 1 year, for example. For example, let's identify a time interval of our own choice. Then we can take a subset of the data sets for the year of interest, then create a column that contains the time interval that each data point belongs to, for example, group by that specific column, and then count the number of companies that join per interval. So we can create trends over time, for example. Yeah. So we can insert a week joint, for example, as well. Specific week joint, then so we have now companies 2015. It means that all the companies who have been founded in 2015. Now let's see from these companies 2015 that we have the joint date of them. So we have a joint date right now. Yeah, we have this joint date of month. We have the month of this joint date. We have understand that how many years it took them since 2015 to join the unicorn status. Now, in order to dive deeper, let's find another thing as well. Instead of month, also create another column which will gives us a week of joining. Yeah. So how to do that? Similar thing that we did above. For example, in companies 2015, which is just only this one specific year, we can insert what? We can insert a column in a specific position. Yeah. In position 3, we can call it week joint from companies 2015. Then we can use the date joint. Then we can use companies 2015. They can be use date joint. Then we can use the DT to not week of the year, but in which format it should be. It should be the format of, in which format it is. It's in format of year. Then it is in format of week and fee. Now you will see how all these things doing here. So in the position 3, it created a column week joint. Ashley, your question is, I hope your question is now resolved, yeah?
Yes, sir. Thank you so much.
You got it how to put it the specific way, so I just put it in the third place, yeah? After the third place. So this is first, second, third, and after the third place, it created a week join column for me. Now, from this, what I have done, I said, I want to know that within 2015, for example, 2017, create a column for me that it should give me the understanding of, for example, 2015, week 51. What is week 15? How many weeks are there in a year?
52.
Ah, that's good. That everyone knows that there's. So this is
It's
20 December. 20 December, it means then only one other week is remained that 2017 will be finished, yeah? So it means week joined. It means in the week 51 of 2017, this company joined the status of unicorn. In week 17 of this 2018, week 14 of this 2000, it means what? This date joined, we changed the date joined in which format? In year. So let's the year be the same as it, then put a dash, then put a dash, then week. So this is W, this WW is then value of that specific week. These are all called regex library from Python. Um, Expressions, regex expressions. You will not dive deeper into all these things. You will just keep it right now to memorize it. I will share with you a source, a website, that you will go there and you will see all these different types of things. These are different types which Python understands and put all such type of things for you. So whatever you want, you can just manipulate with all these different things as I have done here. See? You can do that very easily. So this is how we created this new column. Now let's see, for example, within these companies, we have companies by week, yeah, in 2015. Let's make dot group by what? By date week joined, and after the group by, you have to put a what? Aggregation, which I think one of your colleagues told me previously. For that aggregation, you will use the count value, and we will use the reset index as well. And after the reset index, okay, one more thing we can add here. Let's see. This is how the column works, yeah? Companies by week 2015. It means all the companies, all the weeks, and all the years, yeah? So started in 2015, all the weeks have been divided in a way that the company's 2015 file has been grouped by the week it joined, and by week it joined, and then it counted the number of companies that they have established. And what else we have to do? That we have to do the one more thing, that we can rename the column after the reset index. We can. I just really don't know why you're resetting the index. We have to reset the index, give it a proper understanding for us, that then rename the columns. Which columns? The company column. You want to rename it to company count. You want to rename it to. So this column has been now changed to company count. Okay, because we already did it and we changed the company column to the company count. So let's run this again and try to run this again, because it's not one-dimensional. See, this is week join. We didn't reset the index. So just give me. I'll just remove these ones. we did this operation once. Whenever you're doing it once, then you have to just run the whole thing from because you already did this. The data frame already did the whole thing. So this is so now you know what is the point that we are doing here. The thing is that we just want to understand the establishment of companies by the year that we have that has been established. So week joined and then number of companies. So that's it. I think that would be sufficient right now. We will not renaming it again. If you rename it again, then it will lose the initial status of the companies. Again, it happened. Now, how would you structure the data to observe the trends in the average valuation of companies? So from, for example, 2016 we have, yeah? Now we have 2015. So how you want to understand the average of compare the trends over time, for example? You want to see the comparing the trends over time, yes? From time to visualization of different things, yeah? For example, understanding which trend we have done, compare, for example, trends over time. Now we have a trend over time. So these are all the weeks joined in different companies and only in 2015. So we have companies which established in 2015 and then in different years, weeks, it got joined different types of companies. So this is how we got it from this. But now we want to compare over time. So this is now we have a trend here, yeah. So let's do, for example, a comparison of trend over time. All these studies that we have done, for example, this is all types of analytics that we have to conclude. We have to finalize the analytics. Then after the analytics, so you see these are all complicated calculations. But now we will go step by step when we are getting from calculations from these all difficult charts to visualization, for example. For example, before going to all those details, let's do something else. For example, if we have a box plot of what? X will be companies of what? For example, month, yeah? Y will be, for example, companies years to join, yeah? And one more thing, order. How it should be ordered? It should be ordered by January, February, March, by the order of the month. So just forget about the order now. Just let's make it the same as it is. PLT. Let's show. Let's see what it gives us right now. It gives us a data distribution of what? Here's how we should change these x sticks. So we have to change the x sticks, yeah? Because the x sticks rotation, if it is 45 degree, then now it's understandable. In April, in July, in December, so order is not in months, so just let's make it order by month. Now this is by ordered by month. January, February, March, April, May, June, July, August, September, October, November, and December. You see, these are all the number of the specific number of companies have been established in months, in which months they have joined. And actually, gives us the distribution of years to become unicorn with respect to months that they have joined. So it talks, for example, a company, for example, this much years to join. Yeah. Almost all the companies, it took them this much. Yeah. Around between 0 to 20 years to join and become unicorn. But there are some figures, some numbers, which are totally out of the calculation. Look at this one. Look at this one. Look at this one. These are all called what? These are all called outliers. Now, we will be coming to how to deal with the outliers in our calculations. So it means that these are the numbers. We have the numbers that we had already there, but we want to exclude the outliers. If you're not, so what's now outlier? Outlier is actually a specific data point that you have to understand that the whole general data is including in one dimension or in one set of data points. Only those outliers are falling within outside of that specific data range. This is called outlier. How to detect outliers? In order to detect the outliers, there are different types of calculations, technical calculations from statistics point of view. But from visualization point of view, these box plots are giving a very smart understanding of these outliers. Oh, this is outlier, this is outlier, this is outlier. These are the outliers. Outliers all means these are the 3 by IQR. IQR is interquartile range. It means that if you have this from this which is the maximum coming to the minimum. So it means this is the range of the data from maximum to the minimum. So you can have 1.5 of this, 1.5 of this distance above, and 1.5 of this distance below. So this will be your range of outliers. If some points are falling within these range, it's okay. But if a data point is falling out of 1.5 of IQR, then you have to remove it. You will just drop the data point there. So from such type of visualizations, you can understand that we have some companies, but those companies are affecting our calculation. So you can just simply drop those calculations and just stick to what we are having right now. We will be going deeper and deeper to these calculations and conduct this EDA, which is called exploratory data analytics. For all these things right now, we did not do that much visualization, but we will be the main thing which I was showing to you to tell right now. This only second step, right? We are having here that you have to understand first of all how to deal with the duplicate data, how to deal with the shape of the data set, how to understand the filtering the data on a specific year, for example, how to establish new columns, how to deal with the date format. So in other columns, we had that understanding of, okay, this is text, this is number, this is text, this is float. That's very easy to understand that. But understanding the date column is a bit difficult. How to use specific those date functions within the pandas to understand that. These are the things which today I wanted to present to you, besides the techniques of data visualization. This is the start of your analytics course. We are calling it exploratory data analytics. In Python, it's a bit difficult, but within the Python, you will be having a very huge flexibility of dealing with all these things. So all of these things. But with other softwares, it will be very easy for you. So hopefully for tomorrow, you all will be having explored to this stage the data set. And this data set that I shared with you, you will be having established your notebooks within your drives in your Google Classrooms. And you did what I have done till now. And maybe you're going to do much more more than this, but still this is the minimum that I want to show you how to deal with. So this is the aim of exploratory data analytics. Right now, we don't know anything about the companies. Yes? We don't know about the trend there in the companies. We don't know about the things. The only thing that we got an information that 2015, highest number of companies have been established, for example. That's it. And how many, for example, we can see years to join. Yeah, how many years it took a company to join, for example. We can find the highest number, for example, here. Yeah. So to find which is the highest number in this column, for example. So how much time it took a company to join. See, this shows us, maybe this is now the outlier, for example. And you can find the general IQR, for example, interquartile range out of this box plots, as I mentioned, as I presented to you previous time. The interquartile range in box plots. So from that 1.5 above and 1.5 below, you can keep the remaining. You can just remove the data points in order to make proper investigations and assessments of the data sets. This is how you step by step will proceed with the exploratory data analytics of a data set. And then all these information at the end should be converted into the insights. It should be converted into the decisions, into the wise decisions based on this data and your outcomes. Unicorn data set is one of the very important and main data sets in data analytics. Whoever goes and analyze the unicorn data set, if anyone goes and check your profile and portfolio, if you're a data analyst, you have to have this data set there. So starting from today, 𝗔𝗍𝘃𝗃𝗃, this data, information, knowledge, and wisdom was an activity, an assignment for within the class. One of your guys, they uploaded that on the GitHub, so which I'm very happy with that, and I encourage all of you that whatever assignments you're getting from this class, and you have a proper solution at the end for that, and the solution is scored, and at least you consulted with me if you seem that's appropriate. If it's finally and it's okay, you can just upload it onto your digital profiles. For example, you can upload it on GitHub. You can upload it, for example, maybe in different other social platforms. On LinkedIn, it's very important. There is a point called project. Then I will give you a demonstration of how you will upload your project on GitHub and then link it with the LinkedIn. And from the LinkedIn, you will just also direct traffic and viewers to your GitHub portfolio as well. In this way, you will be having a digital portfolio at the end of this course. And everyone whenever they are checking your name and then looking at your profile, they will have a look at your projects as well. Non-technical audience within the LinkedIn, they will have a look at your projects. And after that, if they click on it, they will go to the GitHub profile of you. And within the GitHub, they will have understanding of what you have done actually technically, because you will upload the Python code there as well. This is how your digital portfolio will work. So my suggestion would be, please pay attention to these projects after this that we are working with all of you together. EDA, Exploratory Data Analytics, is the first project. Second project is Tableau. You have to at least have 3-4 Tableau projects that you have to have on your Tableau public profile. Whenever someone is clicking on your profile, they have to understand how good you are in data visualization. If you're a best data scientist, the best of best, and you don't know how to visualize data, then no one will pay attention to you. So that's done. It is now how the market will work. So please pay attention to the Tableau side as well. We will be working with you on Tableau together as well. This was the start of our data visualization. I intentionally put some technicalities on this data set at the beginning to give you a proper understanding of all those functions that we have to use step by step for exploratory data analytics. Then we will be step by step going to the visualization side as well. When we finish this in Python, we will be simply shifting to Tableau, and then I will demonstrate to you how you will be doing all these steps in Tableau as well. And at the end, you have to create your storytelling points. You have to create a presentation, a small presentation, all of you, out of this data set, and explain the outcomes, the ways that you conducted this exploratory data analytics with very beautifully and visually aesthetic visuals, because visualization is playing a key role. You see, this visual is not a good visual. See, this is a very bad visual. But at the end of this, we will see how we can make it proper and appropriate. This is the aim of our learning. Please explore the data set with yourself as well and see if more insights you can generate from the data set. We will be continuing our lesson tomorrow as well, and tomorrow hopefully we will be finishing this step-by-step exploratory data analytics. And after this, then we will be proceeding with Tableau, and if there is interest existing, we will be also exploring the Power BI as well. But if not, we will be keep a stick to the Tableau, and that's it. So you have to download the Tableau public. From the Tableau public side, you can download the Tableau software into your computers. I think everyone can understand how to install it on your local PCs, and we will be working from your local PCs. And on Tableau public, the accounts that you have, then you can use that in Tableau within your PCs to log in. And whatever visualizations you're doing on your PC, then you can just click on it and it will be uploaded to your Tableau public profile as well. So this is now, I think, the very basics of starting with the EDA and the very foundations of data visualization that we had this at the beginning, all the presentations, that colors, highlighting, annotations, and all these playing a key role, and also that part of first presentation that we deliver to you, data foundations. So please don't forget to review that in. So this was how the first day of our data visualization model that we have had right now. Any questions right now? I am at your disposal, please.
I do have a question. Just open the Tableau website for downloading it. So it's like asking for 15 days, like it says 14 days of free trial. So is it a paid software, or we can use the web version as well? Because like I'm using a Mac and I don't have like access to some crack software, so it's like difficult.
You're not using crack softwares. Tableau Public is free for everyone, and it can be downloaded for everyone. I think you can just have a look how to do it.
Okay,
There
I'll
is
check
no
that.
need to buy it. You're using it free version of Tableau, and you're using Tableau Public whenever you are uploading
Just
our.
check link, and in there like it says just download free trial. Like it doesn't have like a download of the community version or something like public version. That's why.
Yeah, please make a search, okay? I will also share a link with you. I think one of the good things for me, for all of you would be, is if you just make a very short search on websites, on internet, and see if your question is answered there or not. Within YouTube, if you just click in the YouTube link and see how to install Tableau, it will give you step by step everything there. So my suggestion will be that if that always didn't work, so I'm at your disposal that I can help you with how to install the Tableau, because at the beginning I also received lots of questions that okay, Tableau is paid and I cannot create the profile there. While now I see that lots of you have created profiles there. So I will share the link with you, not a problem. And I will share tomorrow, whenever the Tableau we will be starting, I will share my computer, whatever I'm working in my computer, the Tableau, so it will gives you the solution there. So no worries about that. I think that will be manageable. Not a
Okay.
problem with that. Yeah.
Thank you.
There are two Tableaus. One is Tableau Public, and one is the Tableau. So just follow the link, which I think one of your colleagues shared right now.
That's so good. Thank you, sir.
Ilyas, who is Ilyas? Ilyas Mohammadi shared the link. And that's the perfect link. And just put not even your business name, just download the app and that's it. No, Ashley shared, I think. Yeah.
Oh, yes, sir. I shared the executable file, but I'm not sure if this was the latest version. It's the
Not important.
2023.
Not important. Not versions in
Mm-hmm.
Tableau is not important. Yeah. And just do that. Ali Sirat, what happened? Yeah. So if there are lots of things here, you can manage with the file. Okay, officially our today's session is concluded and finished, and I hope everyone enjoyed that. Any questions specific? I am at your disposal, and thank you for the participation.